So 17.6 is about solving equations with radicals. So remember, radicals are like the square root sign. And if I have a number or a variable and I set it equal to 6, the square root of x is equal to 6. Well, you know how with equations, like if I have a plus 7 equals 10, you know how I have to do the inverse operations? I have to do the opposite, so I have to subtract 10 or subtract 7 from each side because it was a plus 7, and add and subtract are opposites. Well, that's the same thing over here. Squared and square roots are opposites. So if I want to solve this one, I can square each side of the equation, and my squared and my square root, or my radical, will cancel itself, and I'll get x equals 36. Then I can always check it because I can plug x back in. Instead of putting x in there, I could put 36, and I could see, does it really equal 6? That was the original equation. I just put 36 in the spot of x. So square root of 36 is 6. So yeah, then I know I have the right answer. So the answer was 36. So the same thing can happen with cube roots. If I have the cube root of x equaling 2, I can multiply each side by the exponent of 3. Oh, I can't get that 3 in there. Just a minute here. Okay, and 3, the cube, or the index of 3, or the cube root of 3, cancels with the cube. So I get x equals 2 times 2 times 2, which is 8. And then again, I can check that. Is the cube root of 8 really 2? Well, yeah, because remember this trick, these cancel out. So those are the basic equations. Now we'll get a little bit harder. So if you have the square root of 2x minus 1 equaling 3, I can solve this because the radical on the right-hand side covers everything, the 2x and the minus 1. So I can square the whole quantity and square the other side. Again, my squared and my square root, or my radical, will cancel. I'll get 2x minus 1 equals 9. Now I can just use my basic algebra. Whoops, 1. And solve. And get x equals 5. And again, I can check it. And it's a good idea to do if you're not sure if you're doing it right. I can plug it back in and see if it worked. That would be 10 minus 1. I'd have to multiply before I subtract because of the order of operations. And that would be the square root of 9. The square root of 9 is 3. So yeah, it worked. If it didn't work, you'll know because you won't get 3 equals 3. You'll get something like 4 equals 3 or 10 equals 3. That's how you know it didn't work. If it checks, it should come out with a true statement. Both sides should be equal. So now, what happens if I have a radical? Whoops. 4 minus x. And I just have a regular constant or a regular number and an equals 8. I can't do that trick of squaring both sides. The reason I can't is because I've got this plus 5 here connected to this square root of 4 minus x. So I can't just square both sides. So I want to isolate the radical. That's the first thing you want to do. So to isolate the radical, I'm going to subtract 5 from each side. Oops. There we go. what I mean by isolate the radical is get the radical by itself on one side. So now I have the radical, the square root of 4 minus x all by itself. So now I can go 8 minus 5 is 3. So now it looks like those other problems that I was doing before. So I can just square both sides. And the square root and the squared disappear, cancel itself out, and I get x minus 4 equals 9. And now I can just do my basic algebra. I get negative x equals 5, and I divide by negative 1 because that's really an understood one, that underwear coefficient, and I get x equals negative 5. And again, I could plug it back in and make sure it works. Again, I don't think you're going to want to do this every single time, but when you're first starting out, if you're just not sure, it's kind of nice because your book is on the internet and it tells you if you're right or wrong right away. But let's say you had extra time on a test. You'd never want to do this on the test for every single problem because you only have 50 minutes for the final. But if you had time left over and you had one that you wondered about. Five, 6, 7, 8, 9, and you get 3 equals 3, so then you know that you did it right. But again, the answer is x equals negative 5. This blue stuff is just me checking it. So let's make it a little bit harder here. And what if you have a radical let me see, minus 1 equals square root of x plus 1. Now all of a sudden you have your radicals on both sides. And so the only option it gives you then is to square both sides. But when you do that, you can't just square the radical, because whatever you do to one side, you have to do the other, and whatever you do, you have to do to the whole side. And so notice that I hooked in this minus 1 right here. Okay, that's really important. The reason we didn't have to last time is because there wasn't a radical on both sides and we were able to move the 1. If I move the 1 to the other side, I'm still stuck, because now I got a radical and then minus 1. So the only option to do is to square both sides. Once you square both sides, you have 2x minus 1 times another 2x minus 1 equals x plus 1, should be saying the square root of x plus 1. So now you're going to have to use that FOIL method, or that binomial times a binomial. So this brings in last section. So I'm going to go square root of 2 times the square root of 2, and the square root of 2, or 2x. The square root of 2x times the square root of 2x. Remember, if you have the square root of 2x, oops, 2, 8. It's early in the morning. 2x times another 1. Remember how the squared and the radical disappear, and you just get 2x. So I know that that's just going to be 2x. So if I have a radical times the exact same radical, then it's just going to be what's in the middle, because they're going to cancel each other out. And then I have 2x times negative 1, and that's just going to give me negative 1 square root 2x. And now I'm going to do the negative 1 through. So I have this one, and that's going to give me another negative 1 square root 2x. Should have wrote this smaller, and that's going to give me plus 1. Okay, and then the other side I'm going to have to do is think about this. If I have these two multiplied together, again, that's a square root of x plus 1 squared. So my square root and my squared, my radical and my squared are going to cancel out. I'm going to get x plus 1. So now I'm going to simplify the left-hand side. So I have a 2x. But I have two of these things that are the same. So I have negative 2 square root 2x. plus 1. So again, it goes back to last section. If you didn't practice enough at factoring or foiling, multiplying those binomials times those binomials, then this section's going to be hard. Those binomials times a binomial is so important for the rest of algebra. I'm going to go ahead and take away 1 from each side. So now I get x equals 2x minus 2 square root 2x. So I just wrote this on the next page, so I have some room. I'm going to do a couple things. I'm going to move this to the other side so all my x's are together. I'm trying to isolate my radical. The reason why I'm trying to isolate my radical is so that I can square everything and get rid of it. So this disappears. I get negative 2 square root of 2x equals negative x. Okay, so I'm going to go ahead and try to make it easier and get rid of all this negative. You don't have to, but I'm going to divide each side by negative 1, so I'm dealing with positives. So I have 2 square root of 2x equals x. You didn't have to, it's easier for me. Now I've isolated my radical. Now I can square both sides. And now it's just like those problems before. So now if I square that, I get 4, because 2 squared is 4, times 2x. And the 2x is because the squared and the square root cancel each other out. Remember, the squared and the radical equals x squared. So now I have 8x equals x squared. I'm going to pull it up here. Sorry, this pen is so fat I can't get it all on one page. I need to purchase a better pen. So here you want to think about last section. I can't just solve it like I did with the ones previously because I've got this squared here. So now you need to think about what we did last section. Whenever there was an exponent greater than 1, do you remember how we set it equal to 0 and then factored it? The quiz that you just took. So I'm going to set this equal to 0. I'm going to pull the 8x over. 0 equals x squared minus 8x. So if you recall, what you had to do is, remember how I just kept saying GCF, GCF, GCF. Pull out your GCF. X goes into both of these. So if I factor out an x, I get x minus 8. And now I've got to set them both equal to 0. So x equals 0. And this is where some people forgot on the last test to set them both equal to 0 to actually solve it. If it just said factor, I could leave it like that. But since it says solve, I have to come out with the two answers that make the equation true. So if I solve both of those, I get 0 and 8. Well, we're not done yet, because the funny thing about these is that sometimes you get an answer that's false. So on these type, you always have to plug back in and check. Okay? So when you get two answers, it's because you're dealing with radicals and you're dealing with anything to another exponent other than 1. And so you always want to check both answers. So I'll check both answers on the next page. Okay, so this was the original problem. Here's where the variable was. And this is the answers that I had from the other page. So I'm going to check the 0 first. So I'm going to take the square root and I'm going to plug a 0 in there. A radical. Okay, and the square root of 1 equals, this will be 0 minus 1. So I'll get negative 1 equals the square root of 1. Well, how can the square root of a positive number equal a negative number? That's not going to work. So I know that this is not true. So I know that this answer right here is false. So it gave me a false answer. I can go back in and I can check the 8. Oops. Okay, and this will give me a square root of 9, which is 3. And let's see if this side equals 3. That'll be 16 minus 1. Square root of 16 is 4. 4 minus 1 is 3. So this gave me a true answer. So that means my answer must be 8. Kind of a long process. I can do the same process, or I can do the same type of thing with the cube root. I don't want to forget about those, that sometimes there's a different index than 2. Okay, so let's think about all those things that we were doing. We don't have to worry about there being an extra number out here, because there's not, so that's good. I don't have to move anything. But I do have to consider that, you know, my variable is isolated, which it is. Okay, so I'm good to go there. And then, let me see, I have to cube everything, because the exponent of 3 cancels with the index of 3. I get 4x minus 7 equals 4 times 4 times 4. That's 64. It's kind of nice to have an easier one after the last one. Okay, now there's no exponents of 2 on my variable, so I don't have to worry about that, you know, solving it for 0 and factoring it and doing all that. I can just go ahead and solve. I'm just trying to give you some different problems, couple of different types of problems you might run into. Now again, if you think you have the wrong answer, you could go back and check it. You can check it in your calculator. Your calculator, it should have a button that looks like that. It has a button that looks like this, and that button will only give you the square root, so the index of 2. But this one, you can actually plug in other index. It's really easy if you look on the internet. If you have your calculator and you Google your calculator, or go on YouTube, how do you do this on this calculator? There's usually some kind of little video that will show you, or you know, go to your local high school and just ask for the math teacher, or you know, go back to your college. I don't know how, some of you aren't very close to the college, so you can give me a call. I don't know a lot about all the different calculators, but I have a couple here. So a couple more problems. They talked about some story problems, and you'll definitely have some story problems on the final. And they wanted to give you a real-life application for this type of thing. They said that if you have the weight of a bird, or no, the wingspan, sorry, the wingspan of the bird, you can figure out the weight of the bird, which I think is kind of interesting here. And this is the equation that they use. So it's A is a function of W. All this means is that if you plug W in, you're going to get A. Now A is the weight of the bird, and W is the wingspan. And they tell you that in the story problem. This is a story problem straight out of the book. Okay, so they say, well, what happens if my wingspan, or my weight, let's see, this is actually the area of the weight of the wing in square inches. So what if they say that the area of the wing in square inches is 600 square inches? Then I can use this 600 to plug in here. So they give you the formula. You'd be better off if you open the book right now and took a look at it first before I start this. I do a very good job here. But they give you that area of the wingspan, and so you just plug it into your formula. Okay. And remember what I said about before you start, you want to look and see if you can isolate the variable. And so you're going to isolate the variable, so you're going to divide by 100. And there's a problem like this, I think, on your homework too, but this one is in the textbook. And you get the cube root of W squared. Okay, so once you isolate the variable, now you're able to cube everything to get rid of the radical. So I have W squared equals 6 times 6 times 6 216. And now think about this. You know that square root, the radical and the square root are opposite. So if I want to get rid of this squared, I can just take the square root of both sides. So it's kind of interesting that I got rid of the radical earlier by cubing it, and now I'm getting rid of the squared by using the radical. Okay, so W equals, and you can just do it in your calculator, and this one is not a perfect square, so it ends up being about 14.7. So I don't get a perfect answer. The other thing that they assume you kind of know, and you have one on homework like this, and you could possibly have one on the final, is they kind of, and you probably do know this, I'm just going to run you back through it. They assume you know Pythagorean theorem. Pythagorean theorem is a theorem that only works on right triangles. Right triangles are triangles that have a 90-degree angle. That's what this little box indicates. Okay, and Pythagoras was a Greek philosopher, and he figured out, he took all these right triangles, and he found out that if you take the legs, the two shorter legs, C is always the longer leg, so that's important. Okay, so C is always the longer leg. It's called the hypotenuse, and you might remember that from high school. A and B, it doesn't matter which one you call A and B, as long as they're the two that make the 90-degree. So Pythagoras discovered that if he took A and he squared it, and he took B and he squared it, it would equal C squared all the time, every single time, but it only worked on these special right triangles. So the book gives you a story problem about a TV screen. And I didn't know this till a couple of years ago. My husband told me TV screens are measured by the diagonal across. So when you go get a TV screen, they don't say, oh, it's 20 by 15, which I think would be what you would say, but they don't. They measure it by the diagonal, and they give you the measurement of the diagonal. So if you know that the TV screen is 20 by 15, and you want to know what would the diagonal look at, so you're trying to fit this TV into the spot on your wall or the little hole in your wall, then you've got to know the diagonal and then shop for it, especially if you're online. So if you think about this, TV screens make a right triangle. So imagine that you're looking at this. Well, Pythagoras said that if you take those two shorter sides, 20, and you square it, and 15 and you square it, it will always equal the hypotenuse squared. So C would be right there. So 20 squared is 400, and 15 squared is 225, and that's supposed to equal C squared. So that's 625. And remember that to get rid of a squared, I could use the square root of each side. So C equals 25. So this is a 25-inch screen. Okay, so a lot of times too, they'll do this. Could I have a triangle with A equaling 7 and B equaling 12 and C equaling, 25? Could that be a right triangle? It could be a triangle, definitely, but can it be a right triangle? So then you have to plug them in and prove it. So like 7 squared, and they might not even tell you A, B, and C. They might just say, I have a triangle that's 7 by 12 by 25. You have to know that 25 is your C because it's the longest side. So 7 squared plus 12 squared equals 25 squared. So 49 plus 144 equals 625. And there's no way that this is going to equal 625. So then you say, no, this isn't a right triangle. So sometimes you'll have problems where you just have to prove it. Okay, so again, the hardest ones are Probably the ones that we were doing with the, where it had the radical and then the number on the outside. So you might want to try some of those, you know, run yourself back through that screen that I showed you. And the book also has an example too. So, but the book also has some examples that you don't need. We've never factored anything with a coefficient greater than 1, and so it did have an example like that that I left out. And, you know, leave some extra time for your homework because this section does take a long time. Okay, let me know if you need help.